Good morning friends. Today we are going to see the competitive lecture number 2 of the topic mechanical properties of fluids. Friends, today we are going to study the topic surface tension and surface energy. So in theoretical part we have studied in detail regarding the formulas. Now based on that we are going to see some MCQs. Now the first question is the relation between ST and SA. ST is the surface tension and SA is the ST is the surface tension, and the SE actually here it should be the SE, surface tension, and the surface energy. Now while studying in the theoretical part, we know that the energy and the work they are equivalent, and the mathematical formula for the surface tension is equal to work done per unit area. Surface tension is equal to work done per unit area. So if we will observe this symbol, so option number C, T is equal to W by A. Surface tension is equal to work done per unit area. Now remember, this work done will be stored in the form of energy, and we can write this as a work is equal to T into A area. So lots of time work is equal to surface tension into the area. It may be also that the surface energy is equal to surface tension into the area. Right. So as per the question, you have to choose option. So here the relation between the surface tension and the surface energy is there. And now if it will be in the terms of the surface area, then also we can write T is equal to W by A. So it will be in the terms of the SE, surface energy, or it will be in the terms of SA, surface area. Okay, so here, so we have to choose the option number C, that is the correct answer. So have you got the idea that we have used the basic formula surface tension is equal to work done per unit area, so that is W by A. So based on that, T is equal to W by A. If the question is asking in terms of surface energy, remember the work and energy are same, so surface energy is equal to surface tension into the area. Okay, so as per the question, we have to choose the answer here. Now we move to the second question. What does the second question say? If a single drop of liquid split into the number of large droplets of the same size, then the energy in this process is. Okay, so suppose if this is a single drop, suppose it is a mercury single drop, and it will break down into the two droplets. So what will happen in this process? So when a large drop will be breaks down into the droplets, in this process the energy will be absorbed. So in this process energy will be absorbed, as option number B is correct. Now if the question is reverse, when the number of droplets are submerged to form a single drop, and in this process the energy will be liberated. So here when the single drop will be break down into the droplet, at that time energy will be absorbed, and if the question is the reverse, then answer will be the liberated. So as per the question, you have to choose answer. Friends, regarding the surface energy, also such kind of the question will be asked. There also you should draw the diagram, and based on that you can get a clear idea. So have you got the answer? That if a single drop of the liquid split into the large number of droplets of the same size, then the energy will be absorbed in this process. Option number B will be the correct answer here. Now we will move to the third question. What does the third question say? It is a numerical question. The work done in blowing a bubble. So friends, here the word bubble is very important. So bubble of radius 0.02 centimeter, and the surface tension is given into the bracket. So what is the difference between the liquid drop and bubble? First we should know that when we are saying about the drop, liquid drop has a single surface in the contact with the area. So while solving this question, we have to use the area as a 4 pi r square area for the drop. If here is the word drop, then we have to take the area as a 4 pi r square. Now when the question is for the bubble, in the bubble there are the two surfaces in contact with the air. So the area we have to take as pi r square. So two surfaces are in contact with the air. So area should be taken as a 2 into 4 pi r square. Right. So you have to read the questions very carefully whether it is for a liquid drop or bubble. Okay. Once you will be clear with the idea, then there is no confusion when solving the mathematical parts. Okay. Now in this question, what we have to calculate the work done. So if we will correlate with the first question, then we can use the formula as a surface tension is equal to work done per unit area. So work done is equal to the surface tension into the area. And now, as per the question, it is a bubble. So we have written T into area 2 multiplied by 4 pi r square because two surfaces are in contact with the air. Now we have to substitute the values. So work done is equal to T. What is the value of the surface tension? 25 into 10 raised to minus 3 multiplied by 2 multiplied by 4 multiplied by 5. 5 the value of pi is 3.142. And here the radius in terms of the 0.02 centimeter. We have to convert in terms of the meter to 0.02 into 10 raised to minus 2 bracket square. So remember, here in terms of the centimeter, I have converted in terms of the meter and I am multiplying with the 10 raised to minus 2. Okay, now we have to do the multiplication. 25 multiplied by the 2, work done is equal to here 50, right? Now 4 multiplied by 3.142, 4 2s are 8, 4 4s are 16, 4 1s are 4 plus 5, 12.568. Now I have done this multiplication, then the power of 10 is to minus 3. Now here 0.02, so you can write as 2 into 10 raised to minus 4 bracket square. Okay, now if we are doing the multiplication, again I can write as 50 into 12.568, here 4 into 10 raised to minus 3, and here 10 raised to minus 8. Friends, 50 multiplied by 4. So we are getting 200 here. Work done is equal to 200 into 12.568 into 10 raised to minus 11. Now here 2 zeros are there. 2 zeros will be cancelled out. You can reduce the power in the 2, and then by the approximation method you can get the idea 12 multiplied by 2, that's a 24 point, and the power in terms of the 10 raised to minus 9. So after here orally also you can do the multiplication and you are getting the answer as a 25.12 into 10 raised to minus 19 joule. Again I am going to explain this question. So here if you do the multiplication, you are getting the answer as a 25.12 into 10 raised to minus 9 joule. So 1, 2 and something number you are getting, but here by the calculation we can get approximately correct answer. Friends, again I am going to explain this question. How to solve this? First read the question very carefully. What we have to calculate? We have to calculate the work done. So what is the formula for the work done? So work done is equal to surface tension into area. Now we have to think whether it is a liquid drop or bubble. Now as per the question it is a bubble. For the bubble, area will be the 2 into 4 pi r square. Now surface tension is given in the question. In value of pi we can substitute, and the radius, the value is given in terms of the centimeters, that we have to convert in terms of the meter. That is 0.02 into 10 raised to minus 2 bracket square. And after doing the multiplication, we are getting the final answer. So in the case of bubble, if there is a liquid drop, then the formula will be the T into 4 pi r square. 2 will not come. Okay. So I hope you have understood this answer. Here we have completed the third question. Okay, friends, now we are going to solve the next question number 4. Question number 4 is the ratio of the work done in blowing a soap bubble of radius in the ratio 1:2 is. Now here the ratio of radius is given and we have to calculate the ratio of work done. So previously we have studied surface tension is equal to work done per unit area. So work is equal to T into A. Now area we have studied that for the soap bubble, it is a 2 into 4 pi r square, right? So here we have to take the relation between the work and the radius, because the ratio of the radius is given and the ratio of work is asked. So work is directly proportional to the square of radius. So the work done is directly proportional to the square of radius. Based on that, W1 upon W2, work done for the first to the second is equal to R1 square upon R2 square, means 1 upon 1 square upon 2 square. So the answer will be the 1:4. So the ratio of the radius is given. So in simple words, you can get the ratio of R1 upon R2 is 1/2. The ratio of work done W1 by W2 we have to calculate. So work is directly, what W is equal to T into dA. For the slope bubble there are the two surfaces, so T into 2 into 4 pi r square. Now W is directly proportional to r square, remaining all things are taken as a constant. So the ratio of W1 upon W2 is equal to R1 square upon R2 square. So 1 upon 2, the ratio is square. So if we do the square, so we are getting the answer 1:4. Option number A will be the correct here. So here also, based on the relations of the work and the radius, we have got the answer. So the relation may be asked is the work and the surface tension and the variable factors. So remember, as per the question, we have to take the ratios. Now we will move to the next question. A liquid drop of radius capital R is broken into the n small droplets of the same size, and the work done is proportional to. Now suppose one big drop is there, and it will be broken into the number of droplets. Suppose small n with the number of droplets. Now we have to calculate the work done. So again we have to move to the next basic formula. Surface tension of work done per area, W is equal to T into A. Work done is equal to surface tension into area. Now work done is equal to surface tension into the area. For the big drop, we can take as 4 pi capital surface area. We can take as a, here we have to take as a surface number of droplets, and when it is based on the drops, so we have to take the 4 pi r square for the surface area. And remember, as it is broken down into the number of droplets, so here we have to take out the volume, because the volume will remain the same here. So here we have to use the formula of the volume, 4/3 pi r cube. Now it will be broken down again, the surface tension will remain the same. Friends, remember, it is a drop and the volume will remain the same. So here small number of droplets, 4/3 pi small r cube. Here in the place of surface area, we have taken the proportional volume, and the volume of sphere has the formula 4/3 pi r cube. So if we observe this, T will get cancelled, 4/3 that will be get cancelled. So r cube is equal to n into r cube. So r is equal to n raised to 1/3 into r. So n raised to 1/3, that is the correct answer. So the work done is proportional to the n raised to 1/3. Because again, if you go here, we have the relation regarding the radius, then work is directly proportional to the square of radius, and based on that, here number is taken as a constant, so it is n raised to 1/3. So friends, remember here r cube is equal to small n into small r cube. We have taken the cube root. For that purpose, we have got the power of n as the n raised to 1/3. So based on this, if some numerical values are given regarding the radius, suppose here value is, suppose 8 droplets are given, then 8 raised to 1/3, you can take the 2r. So as per the question, again we have to solve such kind of a question. So remember, this is an important formula in order to find out the relation between the small drop and the small drops or the large drops. So what is the formula? R is equal to n raised to 1/3 into the small r. Now we move to the next question, question number 6. The question says that a liquid film is formed over a ring having the area. Okay, so area is given. How much is the area? 0.02 into 10 raised to 4 centimeter square. Now, if I want to convert in terms of the meter square, I can write it as 0.02 into 10 raised to 4 into 10 raised to minus 4 meter square. So naturally, I am getting the area as 0.02 meter square. Okay, so area is given in terms of the centimeter square. I have converted it in terms of meter square. Again, surface tension is given T, that is 0.5 Newton per meter. And what we have to calculate? Surface energy. So surface energy is nothing but the work done. So again, here work done we have to calculate. So surface tension is equal to work done per unit area. Work is equal to surface tension into the area. So here it is a circular ring, and when we are saying about the circular ring, the two surfaces are in contact with the air. So here we have to take in the place of A, we have taken as 2 into A. Friends, why we have taken the 2? Because the two surfaces of the area ring are in contact with the air. So based on that, substitute the value of T 0.5 to the area we have already calculated here 0.02. So if you will do the multiplication, 0.5 multiplied by 2, you have got the answer 1, and 1 multiplied by 0.02, final answer is 1. So here 1 multiplied by 0.02, what is the answer? 0.02 joule. So here, friends, we have completed the question number 6. So friends, I hope you have understood the questions. So we have seen the question number 4, 5 and 6. I hope you will try to solve such kind of the question. I hope you have understood the concept of the surface tension and surface energy